Greetings, math fans. All right, so this is day 9. So it's day 9, which is kind of corresponds to worksheet 8. Okay, and the topic is dividing radicals. Dividing radicals. It's a little messy. Sorry about that. Okay, dividing radicals. So we've kind of done a little bit of that. I'm going to actually review just kind of one topic that we've talked about. First of all, the deal is no radicals, no square roots, cube roots, whatever, no radicals in the denominator. Okay, so you just can't have any, when I say the denominator, right, that's the bottom of the fraction. So you can't have any square roots in the bottom of the fraction, none. So let's kind of start out, if I just start out with this, let's say the cube root, let's just do the square root. Let's do a square root first. Square root of x. So here's the deal. My goal, math fans, is I want to get the square root of x squared. Because if I get the square root of x squared, do you guys agree that's just x? Right? It's kind of like the saying the fifth root of x to the fifth is x. The 18th root of x to the 18th is x. So I'm trying to get perfect squares or fifth roots or 18th roots in the denominator in order for I can take then the root of that and then it cancels out. Okay, the square or the root cancels out. So what I need is just like we've done with numbers, we're going to do that in a little bit. I need a pair of these x's in order for this to cancel out. So if I multiply the top and the bottom by the square root of x over the square root of x, what that gives me is in the denominator, I'm just going to look at the denominator. At the top, let's just do it. We get the square root of x. That's great, okay? I don't really care about the top. The bottom now, do you guys agree? I get the square root of x times x, which is really the square root of x over the square root of x squared, right? And you guys agree the square root of x squared is just x. And on top I have that. So this is my final answer. Okay? So my goal again is to get rid of that denominator with the square root. I can have whatever I want on the top, I just can't have a square root in the bottom. That's the deal. Okay? So let's do kind of a little, not really a crazy one, but if I did 1 over the fourth root of x squared. So what do I need here? I need an x to the fourth. So I'm going to multiply this by the square or the fourth root of x squared over the fourth root of x squared. That's going to give me the fourth root of x to the fourth on the bottom, and the top is going to give me the fourth root of x squared. So again, I don't care about the top. I get that. And on the bottom, it's the fourth root of x to the fourth. X, and I'm done with the problem. What? Okay? So it's, like I said, it's really not that bad. Let me just do one more. So if I just, 5 over let's say the cube root of x. So do you guys agree? I need this to be x cubed. So I'm going to multiply this by the cube root of x squared over the cube root of x squared. Because that's going to give me on the top 5 cube root of x squared. And the bottom, x to the first times x squared is x cubed. And then the cube root of x cubed is x. And the top is going to give me just like that. Okay, so that's it. Don't have the problem. So let's do that with numbers. And we've done these already, so this is kind of like a little bit of review for you guys. But if I said, I'm going to stick with 1. So 1 over the square root of 3. So I need to have a pair of 3's to give me, get rid of the square root. Okay? So I'm going to multiply the top and the bottom by the square root of 3 over the square root of 3. So again, the top is going to be 1 times square root of 3, which is square root of 3. And the bottom is going to be the square root of 3 times square root of 3, or here, let me just write it this way. It's a pair of 3's. And remember, if you have a pair of 3's with the square root, it just becomes 3. That's really important. and the top is just square root of 3. So that's my answer. So remember, guys, the square root, so I look at this one, and basically square root of 3 times square root of 3 is just 3. Okay, so square root of 3 and 3, because you got a pair of 3's, that just gives you that 3. So let's do another number. How about 2 over the 4th root of, let's do the 4th root of 8. So what I'm going to do is I'm going to take that 8 and I'm going to break it up. Remember I told you right on top of your paper, 2, 3, 5, and 7. So that 8 I'm going to start dividing, and I'm going to, if I divide that out, I get 2 times 2 times 2. And I need 4 of these in order to get rid of it. So I'm going to multiply the top and the bottom by the 4th root of 2 and the 4th root of 2. Because that's going to give me 4 of these in the bottom. So it's 2 times the 4th root of 2. And the bottom is going to give me the 4th root of 2 times 2 times 2 times 2. And remember, that's just going to give me 2. And the top is going to be 2 times the 4th root of 2. Okay? Now technically, that can cancel. So I just get the 4th root of 2. So if you're good, you look to see what you can cancel at the end. And since this guy here is outside the radical, and that's also outside the radical, they just cancel out. Okay, so we get the 4th root of 2. Okay, let's try one more, and then we get to a little more complicated problems. If I had 5 over the 5th root of, let's do 9. Okay, so let's break down that 9. So it's 5 over the 5th root of 3 times 3. So I need, how many of these do I need? I need 5 of these. I only have 2, so I'm going to do this. Well, 3 times 3 times 3. That's going to give me 5. And the 5th root of that. 3 times 3 times 3. Okay? So that's going to give me 5 of these here. So I can just say that what's the 5th root of 3? It's just 3. And on top it's 5 times the 5th root of, well, I don't want to leave it as 3 times 3 times 3, but if I multiply it out in my calculator, I get 27. So that is my final answer. 5 times the 5th root of 27 over 3. Okay? So that's kind of some basic stuff. We've talked a little bit about that already, but now let's actually get into problems like this. So 2 over 3 plus the square root of 5. So you're going to learn a new word here, and it's based on the bottom. It's called conjugate. And the conjugate is basically you change the sign between the two terms on the bottom one. Again, it's the bottom. So in other words, the conjugate is 3 minus the square root of 5. That's important. So you're going to multiply the top and bottom of the fraction by the conjugate, or 3 minus root 5. So watch what happens. 3 minus root 5 over 3 minus root 5. So this is from just a couple days ago, right? When you multiplied out, or just a day ago. I'm going to multiply that 2 times those two terms, and then I'm going to FOIL. Let me put this in red. I'm going to FOIL the bottom because I have 2 terms here and 2 terms here. 2 terms here and 2 terms here. Okay? So let's do that. 2 times 3 is 6. 2 times negative root 5 is negative 2 root 5. That's the top. Let's look at the bottom. 3 times 3 is 9. So I'm doing FOIL. So 3 times 3 is 9. 3 times negative root 5 is negative 3 root 5. 3 times positive root 5 is plus 3 root 5. And last is root 5 times root 5 is just 5. You don't need to say 25, so it's 5, but it's minus because you got a negative here. So minus 5. So if you notice this, math fans, these middle terms will always cancel out if you are multiplying correctly. Okay, so we're using FOIL, so the middle terms will always cancel out. Always, always, always. Okay, and you're left with just FL, or Florida. I like to refer to as Florida. So these cancel. Negative 3 root 5 plus 3 root 5 is out of here. And I have 9 minus 5. So my final answer to this problem is 6 minus 2 root 5 over 9 minus 5, which is 4. And that's it. That's your answer. No square roots in the denominator, and we're done with the problem. Okay? It's not that bad, but you got to multiply by the conjugate. So let's do another one here. How about this one? I'm going to pick a couple of them off the worksheet here because it can get a little challenging. Let's do a kind of a little simpler one first, and then we'll get to a tougher one. So this is number 5. So negative 3 root 2 over root 3 minus root 5. So what's the conjugate? The conjugate is root 3 plus root 5. So I'm going to multiply the top and the bottom by root 3 plus root 5 over root 3 plus root 5. So the top I'm just going to distribute. So negative 3 root 2 times root 3 is negative 3 root 6. And negative 3 root 2 times root 5 is negative 3 root 10. Okay, the bottom, well, let's FOIL it out. So root 3 times root 3 is 3. Let me just do one more time. The FOIL outside is plus root 15. Inside is plus root 15 or minus root 15. And last is root 5 times root 5 is 5, so minus 5. So again, these cancel. So we get negative 3 root 6 minus 3 root 10 over 3 minus 5, which is negative 2. And we're done with the problem. Okay? Really isn't that bad. Really is not bad. Okay, so let's do a couple of crazier ones. So this is one with variables in it. Square root of x minus the square root of y over square root of x plus the square root of y. What's the conjugate? Again, you're only looking at the bottom. So it's square root of x minus square root of y. Change the sign between them. Square root of x minus square root of y. Okay, top I'm going to FOIL. So I get square root of x times square root of x is x. Square root of x times negative square root of y is minus square root of xy. Inside, minus square root of xy. I could write it as yx, but I like xy because it's the same thing, and then it's easier to add them together. And square root of y times square root of y is plus y. That's what I get for the top. So nothing cancels. The bottom does. Square root of x times square root of x is x. Outside is minus square root of xy. Inside is plus square root of xy. So they cancel. And then minus square root of y times square root of y is y. So my final answer is I can combine these two together. So I get x minus 2 of these. There's 1 and 1. So x minus 2 square root of xy plus y over x minus y. And you're done with the problem. Looks complicated at the end, but it's what it is. Okay? Okay, I want to do a couple more here. And one of them is kind of a nasty problem on your worksheet, and probably going to get rid of this one. But number 11. So it's 7 root 2 plus 4 root 3 over 4 root 3 minus 3 root 2. Okay, multiply by the conjugate. So 4 root 3 plus 3 root 2 over 4 root 3 plus 3 root 2. Okay, it's ugly. You got a lot of foiling to do here, guys, and you just got to be careful. So lots of foiling. So the top is going to give me 7 times 4 is 28. I'm going to write these numbers on the board or on the top here. 2, 3, 5, and 7. Okay, so help me simplify. So root 2 times root 3, I can't simplify, so I'm just going to write it as root 6. Can't do anything with it. Outside, plus 21. Root 2 times root 2 is 2. That's nice. Inside, plus 16, and then root 3 times root 3 is 3. And last, plus 4 times 3 is 12. Root 3 times root 6 is, or root 3 times root 2 is root 6. Okay? The bottom is going to, remember the first and the last are the only ones are good. The outside and inside cancel. So 4 root 3 times 4 root 3 is 16 times 3. Outside, inside cancel. And last is minus 9 times 2. Okay? So got to multiply some stuff together. So it's 28 root 6. 21 times 2 is plus 42. 16 times 3 is plus 48. And then plus 12 root 6. Over 16 times 3 is 48 minus 18. Okay? So you get, if I combine these guys together, which I can, so 28 root 6 plus 12 root 6 is 40 root 6. And then 42 plus 48 is 90, plus 90 over 48 minus 18 is 30. That's it. We're done with the problem. Okay, you just got to be careful, but it's really not bad at all. Okay? I'm going to do one more. I'm going to do root 3 minus 5 over root 3 plus 5. It's another one off your worksheet. Okay, multiply by the conjugate of the bottom, so root 3 minus 5 over root 3 minus 5. Okay, so let's FOIL. A lot of foiling. So the top gives us root 3 times root 3 is 3 minus 5 root 3 minus another 5 root 3 plus 25. The bottom's going to give me root 3 times root 3 is 3. Again, the outside inside cancel. And minus 25. So 3 plus 25 is 28. Negative 5 root 3 minus 5 root 3 is negative 10 root 3. And the bottom is 3 minus 25 is negative 22. And we're done with the problem. Okay? So it really isn't bad. Just got to multiply by the conjugate. And that gets rid of your radicals in the denominator. Okay? So that's it, math fans. You have an outstanding day. Adios. Goodbye.